Yeah, so as I said earlier, I'm a little bit of a eco-warrior. I try to use, for a long time, I try to eat ecological food and have a green bank and try to wear fair trade clothes, all of that kind of stuff, like this shirt, for example. And so when you invest money, of course, you also want to look for where does that money go? Because it's actually, they're doing a lot with your money. And the first thing is you go to your bank. But then you realize that actually there's not much money in your bank account, right? So most of the money that you invest, you actually invest in insurance. You give insurance a whole lot of money over time, right? And then, you get something for that. So I was looking for insurance, life insurance. I get hit by a bus. I'd like my family to not end up under a bridge. So I checked what would be a nice green alternative insurance company. And so I found this company, and I was like, okay, you look good. That sounds amazing what your website says. Send me a contract. And they went, no, we don't do that. We don't do this unread contracts thing. We just have a working partner relationship, so we don't do contracts. You can come by. We have great architecture. We have nice desks. We have the best people working here. They have amazing names like Peter and Michael and Michelle. You can talk to them. And even if you're done with all of that, you can even go to our customers. They also have great names. But you can ask them, given your situation, when something happened to you, then what was the result of the company? Or what was the result that the insurance did? So I did all of that, and it was quite nice. And then I was like, okay, so how do we do this now? Okay, you just wire us money, and if something happens, we got you covered. So who would bet his family's livelihood on that insurance? Why? Isn't that amazing what they're doing? Like clean architecture and transparency. What's missing? Something missing? Paper. What is on that paper? A contract, right? A contract is missing. We're going to come back to that in a second. Once again, my own code of conduct has me here because it used to say some dude who wrote a book. So Uncle Bob wrote this. All comments are always failures. And he has a little bit text before and after that, but mostly that's kind of the opinion that he's putting forward in that book. And I think it's just plain wrong. I think that's a stupid thing to say and a stupid thing to believe. Because the reason is, most of the time when somebody tells me about nice, clean and self-documenting code, I couldn't care less about the code. Most of the code I don't care about. I'm looking for two things usually. When I'm looking for a bug, I want to find out where do things go wrong. I scan through thousands of lines of code, maybe looking for the one place where something goes wrong. Or when I have to put in a feature somewhere, I'm looking for that place where the feature fits. I don't want to read all of that code, I just want to understand what it does. I want to know when I call that method, what are pre and post conditions, the return values, what range will they have. When you look for a bug, that's what you want to see. You want to see, is this where things go wrong? Does it have side effects? Thread safety and immutability, that's really hard to self-document. Those are all things that I care about when I'm looking for a place to put a feature or for a bug. And then all of these things that we say are amazing, good names, small methods, and the solid architecture, they only go so far in helping me here. So for example, one of my pet peeves is you have an interface with 0 comments but 10 implementations. Amazing. How many of those am I expected to check until I have covered what the interface is supposed to abstract over? Do I have to check all of the 10 implementations? That's one thing that I frequently run into, for example. So these things, they are good. I'm going to come back later to that, but they only go so far in what I want. Now let's say I do care about the code. I found the one place where I want to change something. Then the next question I usually have is, why? Why, specifically with bugs, why does it look the way it does? And then once again, I want to know things that are really hard to put into code. If the code looks like this, what was the alternatives that were evaluated? What were the requirements that made the code look weird? Because most of the code looks weird. And most of the code does not look weird because the programmer was weird, but because the requirements just forced the code into that shape. And more than once, I saw a solution, I was like, I don't know who that wrote, but that's a stupid solution. I can code up a better one in an hour. And after like an hour and a half, I find out, okay, I covered 98% of the feature set, but the other 2%, those are the reason why the code looks so crappy in the first place, because there is just no other way to implement 100% of the requirements without, taking these shortcuts maybe, or this non-ideal design decisions. And I want to see that before I do all of that refactoring work, ideally. How does it fit into overall architecture? What are design principles behind that? It's really, really hard to put that into code. Like, your good names will not tell you anything about that. Solid helps a little bit, and if you use design patterns that everybody knows, then that helps as well. But maybe it's just me, but when I look at the Wikipedia list of design patterns, I know maybe a tenth of them because there are so many. And it's not like, so if you use, I don't know, the observer pattern, you have a fair chance that everybody recognizes that pattern. But if you use a pattern that's less well known, maybe it would help to tell people, hey, this is a chain of responsibility pattern. Just FYI, maybe you want to look that up to understand the test, this code. Yes, tests, that's the next thing. Tests are supposed to show me all of that, and I care even less about the damn tests. There are tons of things that are really hard to test. It's not impossible, but it's really hard. Thread safety, mutability, interfaces. Okay, let's say your test covers the behavior of the interface. You can do that. You can write an abstract test class that covers all the interface's contract, and then you have an implementation for that. Like if your class implements that interface, you write a test class that extends that abstract test class, and then it inherits all of those interface tests. I rarely see that. And if you don't have that, if you don't have for that interface a designated test class, then the whole read the test, it tells you what the code is doing. It's just BS. It just doesn't work that way. Also, then test coverage better be really, really high. There are trade-offs involved with that as well, but you can't reasonably expect somebody to understand your code from your tests if you test like 70%. That's not really a good way to forward this information then. The other thing is that in general, tests are observations. So it's just a single data point, and now I have to understand what the code is doing as a whole. I have to generalize that. I have to take that low-level information and put it together. And then also test, like it kind of feels maybe like a contract, but it's not. Like what do? You change a class, a test fails. You fix the test by changing it, right? So like that does not hold the contract fixed in place. You can basically just update the test as you go, and then what can easily happen, for example, is that the actual behavior and the behavior that other classes expect starts to diverge. So tests are like a low-level detail, and they're great. I'm going to get back to that in a second. But they just explain how the code behaves, what it does. They never explain why it behaves the way it does, and always is a bottom-up approach. Also, did you ever hear RTFT? Read the fucking tests? No? What's that thing? Read the fucking manual, right? And it's there for a reason. I mean, even that is borderline asshole move to tell that to people. But read the fucking menu. But even read the fucking test. That's way worse than that. So I think there's a chance to improve the situation with some not test-based and not name-based explanations there. So I harped on a couple of things that I really value highly: self-documenting code and tests. They are important and they're relevant. You should do your best to make that code as good as you can, given the quick and dirty thing that we said earlier. But they are not good at certain things. They're not good if you just want to understand how this big piece of code behaves on a high level. If you want to understand the larger concepts of parts of your system interacting with one another, they can't really tell you that. And the other thing they cannot tell you is the famous why of, the code should tell you what, and the comments should tell you why. Why does it look the way it does? And that's really important information. Another thing is that comments are usually said to be hard. That's Kevin Henney, who I respect a whole lot, wrote this once. A common fallacy is to assume authors of incomprehensible code will somehow be able to express themselves lucidly and clearly in comments. I mean, there's certainly a lot of truth to that, right? If you write code that is horribly complex, chances are your comments just going to repeat the same complexity. But still, I try to turn it around. A common fallacy is to assume developers incapable to express themselves lucidly and clearly in a natural language will somehow magically be able to write lucid and clean code. Because these skills are linked. I assure you, if you get better at one, you will get better at the other. And so you should work on both of them. Then finally, the argument is that comments age, and that's true, comments age, cars crash. If a car crash happens because of negligence, then you might be punished by law. So yes, cars crash, but that doesn't mean that you can just crash your car wherever you want, because apparently it just happens. No, there's still consequences to this. And the same is true for comments age. They don't age really by themselves. Somebody didn't do his work or her work properly. And well then, I'm not saying it should be punishable, well yes, I'm saying it should be punishable by law. But maybe that goes too far. Should at least be punishable by wearing a silly hat or something. So the same thing, by the way, can be said about names. Variable names get outdated all the time, and we just update them, right? And know that IDE, of course, IDE support helps with that, but you still have to spot that that name doesn't fit that behavior anymore and have to make the mental effort to come up with a better name. And the same is true for comments. So don't pour the baby out with the bathwater. there's things that all these things are supposed to replace comments cannot do properly. And yes, there are many bad comments. I'm not arguing that there can't be bad comments. There can be horrible comments. I remember when I discovered the Eclipse template where you could just write a getter and then you just have like the Java.doc comment that says get name, gets the name, and then the like at return the name. It's like that's totally useless. I'm not arguing for that, right? And those comments should be, you can look down on them and you can diminish and delete them, but not all of them. There are a lot of valuable comments. And so I hope I convinced you that it's worth looking into this. And so now I want to talk a little bit about the costs and benefits of comments in general and some observations. And then we're going to look at how you can classify comments. And maybe in the end, if we have enough time, we're going to look at how I would think you could write cleaner comments. So why do most devs hate comments? It takes time, right? It takes time to write. It takes time to maintain. If they are wrong, it's confusing. And then some people say it's obstructing because they take up screen space. Let's have a look at these. What about how expensive, how hard is it really to write a comment? And obviously, writing a comment takes more time the later you do it, right? If you just write a piece of code now and you write the comment immediately or half an hour later, then that you still have everything in your head. It's easier to express. If you write the code first, and then the tests, and then open the pull request, and then it gets merged 2 days later, and then somebody tells you write the comment, and then you forget for a week, yes, then it's really hard to write comments. Do it on time, and then it gets much cheaper. If you want to describe a complex behavior very precisely, which you sometimes have to, then yes, that takes a lot of time. But I would say that in total, if you compare that to writing the code and the test, it's not actually that much. Yes, if after a week of development you spend 2 hours on commenting, then you feel like, wow, I spent 2 hours of commenting. But it's still just 2 out of 40, so 5% of the time, right? So it's not that bad overall. Other point of cost is maintenance. What do you do when code changes? And this is really where we come back later to this point a lot, because this is really the crucial aspect. If somebody wrote a comment at some point, and now the code that is being commented changes, then you basically have 3 options, and all of them have a cost. The first one is you don't do anything, and that will cause confusion. We come to that later, but that is a cost that, yeah, we will discuss that kind of cost in a second. You can update that, and that takes time, of course. You have to figure out where's the comment, what does it say, what should it say, that just takes time. Or you can delete the comment and say, that's outdated, and by the way, all comments are failures, so let's delete that one. But then you still have an opportunity because somebody invested time in the past, and I don't want to repeat the sunken cost fallacy. Maybe that was not the wisest decision, but you're still losing that work that was done in the past. And whatever you decide on, whatever you and your team decides on how to write comments, you have to know how to maintain them. Otherwise, we just fail. Once again, changing comments usually doesn't take that much time. The problem is usually finding them. Like if you change a piece of code, what comments do I have to change? And I'm going to describe later how you can write comments in a way that I think helps you backtracking from the change to the comments you have to change. But the basic rule here already is that the comment and the code must somehow be close. If it's not literally close, like in the same couple lines of code, it should be conceptually close, like, oh, the comment that talks about this method, if it's not the method comment, then maybe it's the class comment, but hopefully it's not somewhere totally different place. Yeah, confusion is a real cost. If comments are outdated, ambiguous, if they're just not helpful, then I'll call it confusion. There may be better words for that, but the point is, if the information is not precise enough, and people rely on that though, then the cost can be enormous. Think about you looking for a bug, and somebody, let's just say something is null that shouldn't be null, and then you check, we have like 1,000 lines of code, lots of method calls, you go through that. Of course, you don't deep dive into all the methods, you just look at the contract, and imagine one of them says, this never returns null. And then you look somewhere else, but then it turns out it does, because the comment was wrong. And then you have an enormous cost. You might have done hours of work now wasted because you trusted the comment. And if that happens too often, then people stop trusting comments. And the great example of that is sometimes people put it on Twitter, like they have their IDE or their code editor set up to put to have the comments in the same color as the background, basically, like white on white, maybe, or gray on gray, so they just never see comments, so they can never be confused by them. I think that's a step too far, but I can see where they come from, right? When you learn to not trust comment, because the only comments you ever saw that didn't lie to you were get name gets the name, and everybody else is everything else is outdated, then that's a rational decision to make. But from there it just goes downhill. Now nobody looks at comments, nobody updates them anymore. Now you lost that. And then yes, some people actually say that, and I think that's a ridiculous argument, so I'm not going to even talk about it. Another thing where I feel that developers really hate comments is because, specifically initially, when you're not used to writing natural language text that is comprehensible and compact and precise, then that's actually work. And I know we like to pretend that we do this for a hobby that actually accidentally gets paid, but it kind of still is our job, so I don't think that's a valid argument. Yes, they may be hard to write, but if it's necessary, you just have to learn it. And then we got stuck in that hamster wheel loop of we do something and then something turns green and then the build is green and then everything is amazing. We get a merge request and then we have a green, check mark and everything's like, nobody does that for a comment, right? A comment just turns nothing green. Nobody ever comes to you and say like, look, you comment on that, like on that Maven POM that I saw. I wanted to update that version, but your comment on why it's pinned to the old version, that saved me a couple of hours of time, I'm sure. Thank you so much for that. No, this is an unthankful job. You will get praise for clever algorithm, you will never get praise for clever comment. I think that's one of the reasons why developers, because I think the other reasons are mostly, you can see why those don't really apply, why it's easy to make them, but they may not hold water. But I think these are some real reasons as well. So I would say get over it. We do this for a living after all, so just do it anyway. What are the benefits of comments? Oh, by the way, if you do have questions and you wait until I make a pause to breathe, that's not happening, right? So just raise your hand and just ask away. Some developers like comments because it does these things. It explains what happens, keeps its abstractions intact. We're going to go over these individually, including the saves lives one at the end. Let's start with explain what happens. If user is logged in since the date, then increase the active user count. And now it's really hard to see, wait, what did I just read? Did I read the code or did I read the comment? Because both of them contain the exact same information, right? So yes, they can explain what happens, but hopefully the code already does that. So these kind of comments really are usually totally redundant, and the only thing they can do, if they have an impact at all, is be confusing because you wait, but the comment doesn't square with the line, what's going on here? So that's the only effect they may have. So unless you're using weird language features, that may not be obvious to your fellow developers. I think these explain what happens comments are horrible. But another thing that comments do is they keep abstractions intact. So this is the map interface from Java. For those of you not knowing, well, I guess most of you know what a map is, right? You put in a key and it gets associated with a value. I think in JavaScript you call this an object. And they just do that. Yes, also map? Okay. So the thing is, here you go. Associates the specified value with the specified key in this map option operation. That's great. Just tells me what it does. Have a look at the hash map implementation. I give you 2 seconds to give me the same explanation. I dare you. It's not, you won't make it. Just looking at the hash map put implementation takes you a while to understand what's going on. Because it's a complex implementation for a high performance collection, and this is just a single sentence that you can immediately understand and then move on from there. So ideally, every unit of code has some kind of abstraction, method, class, package, module, whatever. Each unit of code has an abstraction. It should do one thing and do it well, and you shouldn't be concerned about how it does it from the outside. If you want to change it, sure, go into the code, enjoy that it's clean code, do your change. But most of the time, you just want to see from the outside what it does. And this abstraction only really provides a value if it's easy to reuse, if it's easy to see what the abstraction is and then mentally move on from there. You need to modularize any non-trivial problem, and you can only solve it if you can take a cut at some point and say, I'm not going to go deeper into that. I'm not going to look at hash map put. I'm just going to accept what the comment says and use that abstraction as it is. So you can reuse the code that's there easier if it explains well what it does, but you can also reuse the mental work that got into defining that abstraction, that understanding that your fellow developer had about how the text code in, I don't know, Switzerland works, and put that into code. If you write above that, look, this implements the law, I don't know, that paragraph, and then you can reuse that understanding and reuse that in your solutions. And comments can help with both. We're going to look at that later. Another important thing is how you try to understand code. And most people learn better top-down. Usually the best teaching material is one that starts at a high level and tells you, look, this is what lambdas are and what the intention is, and now let's see how a lambda is defined and how you can use it in a Stream API, and then maybe in the end you look at how invoke dynamic is used to actually implement them in the JVM. That's the way people usually learn. Giving you the JDK tests for invoke dynamic and for lambda expressions and then work your way upwards from there is a horrible teaching method. Nobody in their right mind would write a book like that. But we somehow expect developers to understand code like that. Here, look at these 10,000, well, maybe it's not 10,000. Let's have a look at these 200 tests for the interfaces and all its implementing classes. There you go, you have 200 pieces of information. Generalize it on the fly. Comments can be signposts telling you, look, this is what you need to know, and if you want to go deeper, you can do that, but if you don't, you can stay on this level of abstraction. You can document intent. This one, for example, ArrayList has this this object array here, which contains the actual. So ArrayList in Java is an array that acts as if it were a list, and so it has an array for the content, and it's an object array that doesn't matter. Transient doesn't matter. What you should ask yourself in Java is, why isn't this private? This should be private. It's an implementation detail, but it's not. Why is it not private? Because of that. That's good. If I would look at that code, I wouldn't know. Even now, I'm not exactly sure what it tells me, but it does tell me something. It tells me this is not an accident. Somebody thought about this. There should be a picture here, but I'm offline, so it's not. I'm sorry. So yeah, my Wi-Fi broke. Like literally, I think the Wi-Fi card broke. Anyway, so the context of how code works, you need to know that when you go look at other people's code, or even at your own code later. And there are lots of other things that may contain these pieces of information. You can use your commit messages or issue trackers or Jira, or Confluence pages for that. We're going to look at that a little bit, but most of that, to reconstruct that, takes time, and you do that, and then you go to vacation, and the poor SOP taking over your issues. Now they have to rebuild the same understanding, because they have to go through the commit messages and through the issues, and eventually to some outdated Confluence side where an architect took a picture 2 years ago of a whiteboard drawing and tried to understand everything again from scratch. And when the code fails to explain everything that it should explain, and I think that it will frequently do that because it just can't, then comments is the next line of defense against not understanding something. And then come the other tools. That's what I think. If you do take documentation seriously, then this is something that I observed a couple of times on my own, but Mike Bostock put it in great words. It's funny how writing documentation can spur redesign. It's easier to simplify a complex API than to try to document it completely. So we wrote the API and think it works nice, like your code uses it well, and then you start documenting it and you realize, oh wait, no, you have to call that one before this one, and then, but not in that case. And if you start having more and more ifs in your documentation, you start to realize, wait, this is not easy to explain. Then it's not easy to use either. And then maybe I should do something here. And you might realize that while you're writing the comments, because you're becoming your own reviewer there, because you changed hats from I'm the implementer of this API to how does the user of the API see this. So it can take a long time to describe that behavior specifically and well, and maybe the code needs to be improved if documentation takes a whole lot of time. And then finally, comments can save lives. Always code as if the guy who ends up maintaining your code will be a violent psychopath who knows where you live. Code for readability. There should be a picture here of, what's his name from Shining? With the axe, looking through the split door. See, right, so just imagine that person would look at your code next. Maybe that helps you give the motivation to go over that, comments are kind of hard thing. I want to put in a few observations about code in general. We're going to look at how current they have to be. Currency is a weird word, but I didn't find a better one. How close they have to be, and about some of the alternatives. So how up to date do comments have to be? Obviously, some comments, like the one on put, has to be pretty up to date, right? If hashmap put tells you that it associates the key with the value, but then somebody changed the implementation and it doesn't do that anymore, then that's a big problem. But if the comment tells you we implemented it this way because of X, Y, Z, check the issue over there, then that comment doesn't really have to be that well maintained. It's not totally up to date. That's not such a big loss. So not all comments are equal in this regard. And this influences how hard you have to work to maintain them and how much confusion they can actually cause. How close does a comment have to be? Once again, some of them have to be really close. The only good place for hashmap put is on hashmap put. There's not a good place to put that comment. But once again, if you just describe how a class overall behaves, then you don't have to put it on each individual method, right? You just put it into the one place in the class, maybe. We're going to see later how that usually works in Java. And the bottom line here is, the further away the comment is, the harder it gets to update them. The harder it gets to find them, not the updating itself, but finding them. So that's really critical, trying to put comments where the target of the comment is, or at least in a path that you can reconstruct and find. Tons of alternatives. I talked about clean code already, tests or demos even, right? So tests are more aimed at, does this code still do the thing that it's supposed to do? Whereas a demo can be, this is how you as my fellow developer who starts using this API can start using this API. Demos, for example, specifically if you have an open source project, that a critical part of your documentation. JUnit 5 does that very excellently. They have the JUnit 5 user guide pulls code from actual classes, from actual demo classes that are built on each build and pulls them into the documentation. So if those demos fail because the behavior changed, then the build doesn't complete, including the documentation doesn't get built, right? So they have the demos are all run against each individual build, as opposed to having demos just in text files, and then they get outdated too. So the demos can deliver a lot of information. Of course, your version control system is great for that, right? Git messages are important, or whatever else you're using. Mercurial, maybe? Subversion? And the whole dizzy part of the grid, no, yes, not on Subversion anymore. Anyway, issue tracker wiki, these are all important sources of information, don't get me wrong, but they don't work well for each case. And so now I want to look at those cases. I had made this list of kinds of comments, and I'm not claiming that they're complete. I invite you to tell me where I got it wrong and to extend that list maybe. But those are the 4 that I identified. And that split is already sometimes a little bit tough to make the call on which part you belong. So let's start with narrations. Already had that earlier, right? This is the example I already had. Active user count since that date, blah, 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 blah. Okay, that's, first of all, stream pipeline would do that much better, I think, by now. But the thing still is, the comments explain what the code does. And I tend to call those narrations. They just narrate the code. And if you have a friend who always repeats the obvious, you occasionally want to ask him, like, who are you, the narrator? That's that kind of thing, right? So the code just repeats redundantly what's already there. And they're usually very technical. You usually can't really use that. If you really didn't understand the code, then they most likely won't help you either. And if we score them, then we will see that they have to be very up to date, they have to be right on the narrated lines, and there are tons of good alternatives. Just name your variables properly. That's much better than putting a comment there, and we all know that, I guess, so I'm not going to go into that too much. Neither will I go into this too much. What I try to do here is the 4 costs: composition, maintenance, confusion, abstraction, to value that against the benefits of explanation, abstraction, top-down, and intent. And I'm not going to discuss each of these bar charts individually. First of all, I have no data to back this up. Basically, I just pulled these numbers out of a dark place because I think that makes sense and they prove my point. But so you can tell me, like, no, this should not be here, it should be here. I'm open to that discussion. But overall, I think we can see something here that we know about these kind of comments. They're a lot of work and they don't give you much, right? So it's like a pseudo-scientific explanation or data point that supports that. There might be exceptions though. So to those Java developers out there, what am I doing here? Correct? I'm building intersection types with generics, right? So just in case you didn't get that, maybe it helps sometimes to put a comment there and say, look, I'm using language feature in a weird way. This is what I'm doing here. So this is would also be a narration in the end, but it might be a narration that could actually be useful. I'm not saying you should write this code. Well, not in this talk. There's another talk where I tell you that. Anyway, then there are other things like this one. I found this code. Where did I find it? Yes, I found this code in the JDK. This is weird. So this is in the class output stream. And this output stream is some specific output stream. I forgot which one it was. And it basically wraps another output stream, this inner one. And why does it do this? So you call close on that outer output stream, and then why is the try here? What does the try do? Oh, it doesn't. Yeah, that's the point. The try, I just thought I put it there. It closes this one. So the try is used to make sure whatever happens here, we close that stream. I would argue that's the narration that tells you why that is the thing that is being intended here helps. Even though it doesn't add anything to the code, it just repeats what the code already does. But I would argue it may not be obvious that the code does that. So on the rare occasion where you do something like this, maybe a comment helps. So overall, narrations suck unless you use some weird language feature. You feel like there's no better way to improve the readability. go ahead. But by and large, we know that they're not good. Let's get to the initial example with the contract. So map.size. To those who are not Java developers, let the Java developers tell you what map.size does. What does it return? No, but what would you think what size does? Come on, it's not a trick question. Right, returns the number of key value mappings in this map. So now that's a trick question. What comes up now? Well, obviously, the map can have more members than int is high, and then what do you get back? When you have an array that is larger than int numbers of elements, well, then you get integer max value back. That's not obvious, but this is promised by the API, and it's good that it says that, because it's a weird corner case that you might not have thought about. So size, I would claim, covers the first sentence pretty well, but the second, how are you going to put that into a good name? Size unless integer max value, in which case it is integer max, so right? So usually contracts are in Java. Now we're going a little bit more into Java territory, because I'm always going to tell you how to write these comments in Java, but I'm sure other programming languages have similar facilities, and it makes sense to identify where to use which. So the Java doc is usually used on classes and methods, and they try to describe the code's central abstraction, right? Just a sentence specifically on a class, just a sentence saying what this thing is supposed to abstract over and what's supposed to give me what abstraction. Pre and post conditions are nice. Not all methods need this. You don't have to write like something like this. Well, doesn't make sense for all the various method calls you could have, but some of them, that's an interesting post. Or actually, is that a post condition? No, post condition would be if it changes the state, right? How the state is different afterwards. Well, you get my drift. So if it does something that you may not expect, then it makes sense to document that. And if the API is just weird in a certain way, like remember, sometimes when you call this, you get an exception because you didn't call that other thing before. I don't know, that kind of things. If there are a contract, if you're willing to commit to that behavior. So they have to be very, very up to date, obviously, and they have to be right there on the class, on the thing that you're defining. You can get away with good names and tests, but I think only to a limited degree. And once again, we turn to our to the bar charts. So let's just go here. Let's just say abstraction. You can automatically fold them, right? Composition and maintenance are high because you have to be precise and you have to explain that well. You have to keep that up to date. And if they are wrong, then they're the worst comments to be wrong. So lots of red. But also, they keep abstractions intact. They help you understand code from the top down really well. Once again, look at the map interface. I mean, the comment is huge. The comment section on all of that is huge. But like, if you wouldn't know what a map is, look at the Java doc for a map, and you will know what a map is after you read that. And then the same for the individual methods. It really helps you understand how a map works without you having to check how a hash map, or if you look at the concurrent hash map, it's even way worse to understand that code. It's like there's so many things covered in there that it's not easy to reconstruct the abstraction from just looking at the code. So I would say this is complicated. Contract comments, I think they're very valuable, but they do have a high cost. But these are not equally distributed. If the code changes a lot, then you will have to keep updating that. That's where you take a lot of time then, right? Because if you look back at this, yes, composition takes some time, you just do this once. This is where what happens under change. So there's a lot going on there. So I would say if the code changes a lot, then the costs are high. But if the code is used a lot, then the benefits are very high. So if it's used a lot, you read a whole lot. And I would say, if you have pieces of code, like the typical utility classes that everybody and their dog uses in your code base, then that's a great place to put Java doc comments. First of all, you cannot change the behavior easily anyways, because most likely trying to call sites depend on that specific behavior. So it's not like changes are common. But then also, everybody uses them a whole lot, so it really pays off. If I read that method call, I can just look at the Java doc and understand it. If on the other hand, on the other end of your application, maybe where you have like the top layer would just do business logic or we just use UI, then that code might be a lot of churn there because requirements change a lot and business rules change a lot. And nobody really calls into that code that much, so maybe it doesn't, there's no benefit then anymore. So this one is harder to judge, but they still have a lot of value. And if you think that contracts are useless, I dare you next time you use an API, new one that you didn't use that, don't look at the Java doc. And I think afterwards you will agree. Let's have a look at context. hash map. When keys are comparable, so I know that's a change in Java 8. When keys are comparable, this class may use comparison order among keys to help break ties. So what does it mean? A hash map essentially has like a small tree, and then you create for a key, you create the hash, and then you have a look at where in this tree of things do I go. And you have buckets at the bottom. And if the distribution of the hashes is really bad, you end up having lots of keys, or like most of the keys even in one bucket. But the bucket is just a linear list. So you might have like a cool tree structure, and then 90% of the elements are in one long list. And that's horrible performance. So in Java 8, the improvement was made. You know what? Let's check whether k is comparable. And if it is, if the key is comparable, then we can actually build a binary search tree instead of a bucket. That's nice. This is, right, it says this class may use comparison. This is not a contract. It's just like, this is a possibility. But let's say now I want to change that class. Look what we have here. This map usually acts as a binned bucketed hash table, but when bins get too large, they are transformed into bins of tree nodes, each structured similarly to those in Java util tree map. It's basically what I just told you. This is an actual comment in the actual class, and it's amazing because if you have to touch that class, you get information that is not a contract, that's not promised to the outside world, but that gives you technical context on how this thing works and how you can change it and what you have to keep in mind while you work with that. Because this thing, you will see that in a lot of the get and put and changing methods, many of them will have to work, have to have a special case. Oh, am I in this binary tree mode? Then I have to do something different. So you will touch on this in a lot of implementations, and it's great that there's one place introducing to that, that element. Okay, I think that was actually our code base where I found this. We had this. Try this, then try that, and then fill zip file, and then I was like, well, that's stupid. I know better. Because you can do this. You can have one try with both of these things. But it doesn't work. And it doesn't work because when this stream closes, it writes a couple of bytes into that byte stream that finalizes the zip file. If you do it this way, then you turn the output byte stream into a byte array, then you return that, and then they write the finalized zip finalization into that thing. Right? So this code was weird but correct. This code is much better but wrong, and even though I prefer it, I kind of get the point why I should write that code, but the person writing that actually knew what I learned the hard way, because I would guess that they didn't write that accidentally that way. A comment here or here would have been amazing. Technical context. Why does the code look the way it does, if it's not obvious? These are often non-Javadoc blocks, right? So not the /*, but just /*. They're always at the beginning of a class or a method. But since Java 8, there are cool new things. There's @rp node and @impl node that you can use for these. I'm not going to go into detail on that, but if my slides are online later, you can click on these, and then you get to a blog post that I wrote, or you can just Google rp node and impl node. And they're great ways to clarify, to write technical context comments. And they should clarify what code is for, how you might use it, how you might not use it, how it's implemented. Basically, you give advice to the developers going into that class. But remember, this is not a contract. You're not promising that. This is not a promise, right? It's just that's the way it is. And you can already see, well, if that's not too up to date anymore, then that's not the worst thing. So because it doesn't have to be very close, it doesn't have to be very up to date, it comes out like this, I think. Takes some while to write them. You often don't have to maintain them much. It's unlikely that HashMap will change that radically. And if they do, they have a lot of work ahead of them. It doesn't really matter whether you also have to change that, I don't know, 10 lines of comment at the beginning. Yes, if it's outdated, it can be mildly confusing, but I think it's not that bad as a bad promise. But the green side looks better, right? So green, better. I think that's a clear winner. I think the costs are moderate, the benefits are considerable. Whenever you work on something, and it's not immediately obvious what the solution might be, that you actually have to think, or even write one solution and then write another solution. Why? Keep that in there. Updates are another good example. If you pin a specific version, you found out that if I update that, I have to update that, and I have to update that. And you know the third one that actually isn't captured by the tests, but at runtime, sorry, but on customer side, it will still fail. Okay, so I can't do that update. Amazing. Now I update the application to Java 13 and I repeat the same chain, which takes me like a day, over, because nobody put the information there. We cannot update this because of X, Y, Z. So these kind of comments are amazing. And then historical comments, why does things look the way they do? And I give this example, but I was told on different occasions that some people did actually find better code to express this. First of all, it's a stupid way to implement that. I just made I made this example app and didn't do a good job at it, I think. So what's happening here? While true, find a color, but if it's whitish, then not. What? In China, white is often seen as a color of mourning, and some Chinese users did not like it. We hence disallow whitish colors as favorites. For details, see issue, blah. Maybe you could express that better in code, but we know these kind of things. We know this, oh my God, it would be so simple, but now we have this specific requirement for just this one customer, and it warps the way the code looks, makes it look more complex than it has to be. But no, it has to be that complex. It's just not obvious why. Why is important here. And you can document paths that you didn't take, as I mentioned earlier. So they don't have to be up to date. It's a historical marker. They're basically outdated immediately because you just wrote about one specific point in time, but that is always right. That's like a commit message, right? The commit message is always correct. Well, if it was initially correct. Because you wrote it at a point in time that's visible, right? It doesn't get swept over history and you feel like, wait, does that still apply now? No, you know when a commit message applied by the time you made the commit. And this is the same thing. Like you write about, we did X because of Y. And that is always true, even though the code might change afterwards. Commit messages are good alternatives to this, or issues or wikis. But once again, I think that they make sense to put them into code. And you don't have to maintain them. Like we did X because of Y is always correct. And they don't have a lot of other impact, but they still help a lot with identifying intent and understanding why code looks the way it does. And I think they're even better than technical context. And I love when I see them, when I track down bugs. And I miss them a whole lot when they're there. Another kind of comment that I skipped earlier. There are more. There's a link to a Stack Overflow page. I'll store all of them from Stack Overflow. Some of them are very humorous. Some of them obviously express guilt towards your coworkers. I'm not sure if we need this, but I'm too scared to delete. Who has done that? No? Oh, come on, people. When I wrote this, only God and I understood what I was doing. Now only God knows. I come into a class, I'm like, who wrote this shit? This looks horrible. I use Git, and I stop asking that question for some random reason. Because a half a year later, and I forgot what I did. I dedicate all this code, all my work to my wife, Darlene, who will have to support me and our 3 children and the dog once it gets released into the public. And finally, this is the best one. I think it's PHP. Replaces with the spaces, the braces in cases where braces in places cause stasis. Amazing. So yes, comments can be therapeutic as long as you don't actually swear at your individual developers or colleagues. I don't mind the occasional comment like that. It makes me smile, it makes me laugh. So I think that's a fair game too. So let's have a look at the clock. Yes, we got sorry? No bar chart, no. They're all green, it's just amazing. Oh yeah, they can be everywhere. Look, they don't have to be maintained. It's like, they work well. So now we have 10 more minutes to have a look at how we can try to write comments that are clean. Of course, clean comments obviously is taken from clean code, but it's mine. Let's have a look how far we get. All comments are failures is just a silly thing to say. I hope I convinced you of that. And instead, comments are a tool like any other tool. And that doesn't mean that it's universally good or universally bad. It's just there are places where it applies and places where it doesn't apply. And we should educate ourselves about which it might be and then use them wisely. Well, coming back to clean code and tests, do that as good as you can. I'm not saying, my code looks bad, but I'm going to write a comment. That's not what I'm arguing for, not at all. Do the best to write good code, but after you invested a considerable amount of time into that, put the icing on the cake, put a little bit of time into comments. Try to make obvious what kind of comments there are. We're going to come back to that in a second. Strive for proximity to make sure that you can find them later. And the third one is challenging. There's no recipe for that. Try to use unambiguous language. Try to be precise about what you're describing, what you're not describing, and also get versed in reading it that way. Don't read a comment like what you would wish the method would do, but read the comment as what the comment actually says the method does. And consider not only the person using the API, but also the person changing the API on the inside. Because those are 2 different points of view on the same piece of code, and you should have different comments on that. And if you do code review, if you do pair programming, where you look at the piece of code before you commit it, or if you actually have formal reviews, then comments are a part of that. Comments should be reviewed. Not only the comments that are added or changed, also the comments that are not changed should be reviewed. Does this still apply? If you go for narrations, avoid them whenever possible and strive for clean code. If you still have to use them, then it's common to use the // in Java that usually plays directly on that line. Let's get to contracts. What would clean contracts look like? I would recommend to at least describe every top-level element. So let's say each class and interface to get you started. And I'm sure if you look at your code, you're going to find the odd interface that maybe it's not entirely clear what it does, but like a sentence or two would really fix that. And that's a minimal amount of work. And I really advocate a lot for that. And I failed a lot with that as well, because I was the only one having that opinion. Maybe I can convince you now. But yes, I think that's very necessary. So at a code base that I occasionally work in, they use the I for interfaces in the beginning, which I don't like, but it has one advantage. If you open your IDE of choice and you just type the capital letters of the class names, right, it will just filter the entire list down. So you can very easily identify all the interfaces. So once we played that game, start with capital I and then type letters until just a few interfaces remain. Open that one. Tell me in 2 minutes what it does. Like, the people working with that code for years failed at that. And it's not their fault, it's hard to do that. It should have had a comment, that was my intention, not you're too stupid to understand the code. It's normal to be too stupid to understand an interface with 10 implementations in a minute or two. No, the comment should be there to tell you that. And if you start with that high level of, this top element of abstraction, then decide where to go from there. And there was a phase in my life where I put a Java.doc comment on all the methods down to private. Yes, diminishing returns. That was not a good decision, right? So look out for where it still makes sense, but starting there, I would highly recommend that. And how many and how detailed you go depends on many factors. The larger the team, the more likely it is that comments help a lot. The more technical backgrounds you have, the more likely it is that they help a lot, right? If we're all like 10-year senior JavaScript developers, we know all the kinks of the languages and of the APIs, everybody knows how jQuery works, that's great. But if you have a couple of Java people like me in there who get confused what this means, then more comments might be more helpful. And the more stable the code base is, wait, is that right? No, the team, right. The more stable the team is, the fewer comments you need. Right. Whew. Code base, the larger the code base, once again, the more comments you might need, because you can only keep so much in your head, the more technologies you use. And interestingly enough, if you do have code ownership, and I'm not advocating that you should have it, but if you do have code ownership and somebody's in charge of all code that touches X, then interestingly enough, you may need less comments. Having less comments might also cement that situation that you don't want to have, but be that as it may, right, so that person knows all about that piece of code and you can ask them for information on that. Maybe you need less comments. Just an observation, I wouldn't go for that. How do you write clean comments? In Java, you use the proper Java.doc tags. For REST, there are a couple of tools, for example, and all the languages and many approaches have something like that for that. When you write a contract, it's important not to get bogged down in implementation details. Quite the opposite. You don't want to promise how something is implemented. You want to tell what something does, what the result is in the end. So if you think in declarative and imperative as terms, it should be declarative. And yes, try to test that, what you promise, right, just in case. Then technical context, how do you write clean comments like that? When you have a non-trivial implementation, when you trade it off between different alternatives, when there are specific requirements that are non-functional. We have usually functional requirements, right, which are what the customer wants us to have. But we have operational requirements, which are how can this be performant, how can this be automated, that kind of stuff. And then we have developmental requirements, how to write code clean and solid and stuff. And these are not the same sets of requirements, and these ones are really benefit from technical context comments. Look into RP node and impl node. They're a great way to do that. If you don't want to do that, they're usually multi-line comments starting with a / at a start or a type of or a method, right? Like in HashMap, the implementation detail about the tree thingy, that was one of those blocks. It doesn't have to go in that much detail. And you can, I do tend to cite or link issues or wikis in that. I know that's a problem there because if the links go stale because you switch from Jira to GitHub, then all the links break possibly, so I get that that's a disadvantage. But I think that usually you keep the old stuff around, they're still valuable. What about historical context? Very similar to the one before. If you have non-obvious requirements, you want to write that down. If you have temporary solutions, do write that down as well. If you tell someone, look, I know this is not the best way to do this, but it was the only solution I had time for, Don't be ashamed. Put that in there. It's better than the next person deciding, oh, I don't know how to do this. Let me check other classes. Then you find that class, and then then I use that approach, and I use it a couple of times. After 4 weeks, someone tells me like, no, we don't do that anymore. Damn it. Like the comment saying we don't do this anymore would have been great. Once again, you can cite tons of sources. And a side note, I already mentioned that earlier, it's not just about Java or JavaScript source files. Build tooling will really benefit from that. Everything that's about configurations, which is why JSON is such a great documentation format. Configuration format. My YAML files are more commons than, like my YAML for CI and stuff, are more commons than YAML lines, because I don't understand YAML very well and don't understand Travis very well. I need a lot of explanations to understand what's going on. And I occasionally even have comments in my ASCII doc files, which are a comment, right, or documentation. So yes, you can do that too. If you want to maintain comments, you have to find out what code changes. And this is the best way to do that. Let's say I change a method. The code that is impacted by that is a class around that person calling that method and the tests. And I should be able to find, if I change a method implementation, I should be able to find the places where I should change comments by going the other direction, by saying, okay, I changed this method, who calls this, in what class is it, and all the comments that apply to this method should be there and not somewhere totally different. So when you write a comment about a method, just think about it. If that method changes, will you find this comment again? And if you do, that's great. And if not, then maybe put the comment somewhere else. Or I said that if you do pair programming or code reviews, keep comments in mind, and also look out for those colleagues of you who always say comments age. Because mostly those are the people aging the comments. So, make a mental note of anybody in your team discussion saying that I don't want comments because they age, and then look at their commit specifically. Yeah, it's a joke, but still, it's a half joke. You shouldn't be pointing people out publicly. That's not okay to do. But yes, if you as a team decide something, then these are maybe people who don't stick to the agreement. Anyway, avoid narrations, describe central abstractions is my advice. Talk more about contracts and how you want to use them, and if you have context information, always use it. And you do that by getting the team together and speak about that. This only works as the team works as a whole, and that's why I stopped pushing for that in other teams, because it doesn't make sense. I can't write comments on my own. I once wrote a comment. I had a utility class. I created a private constructor, which is common in Java to prevent instantiation of that class because it reduces the amount of confusion they might otherwise cause. But it's weird to have a private default constructor that does nothing. So I put a comment in there, empty constructor because of utility class. And literally 2 weeks later, I found a couple lines of code below that comment. I was like, damn it, it would have been so easy to just delete the comment that claims that it is empty. And you cannot do that on your own, right? If you have to make it as a team discussion, but it can only be a team discussion if the team can speak freely about this. And if you have people saying you want comments, you're just too stupid because you don't understand how clean code works, then the discussion is over really. So you can't have it. And the thing that we did with the interfaces, discuss concrete examples, bring examples up of where you missed a comment or where you did find a comment and you thought it helped you a lot. And in the end, decide on something that you can do as a team and then keep track of it over time in reviews and retrospects and everything. And that was it for me. I usually talk about myself, but I think I don't have to do that here. Image credits, blah, blah, blah. Thank you very much. And I'm going to now take you to Q&A. Ha! On time.